Hi, we're going to talk about shared data pattern today. This is for fulfill my requirement for the assignment for software architectures and patterns. So first, an introduction into shared data. Right. So as the name suggests, shared data is used for sharing a single data source between different components of a system. As we all know, a single system might have several different computer components all interacting with each other. So we can classify these components into two types. Okay, the data accessors and the data repositories. The data repositories, they function as permanent storage. Okay, basically they are the database. They also handle synchronization problems in the case of concurrency. What synchronization problems mean is, since these data repositories are being accessed by several different accessors, right, they will need to be sure that if a certain accessor comes in and modifies, another accessor can see the changes, right? If, for example, another accessor does not see the changes in time, they might be actually modifying it two different ways, which cannot actually occur, so, and that will cause like undesirable consequences. So that is why it needs synchronization. Uh, Other than data repositories, we have data accessors, which are components which can read and write updated data to the data repository. And there are also data read and write connectors. Okay, so a shared data resource can either be an active or inactive resource. What an active resource is that any modifications performed on the resource data will be transmitted to all of the system components. As for an inactive resource, the system components can read and modify the data whenever they require. So this is a very simple diagram of how a shared data architecture looks like. As we can see, there are several different applications here, okay, all interacting with the same database. So perhaps each application can both read and modify from the database. If, for example, two applications want to read and modify the same thing, it is up to the shared data itself to synchronize them. Perhaps it will stop one and allow the other, or perhaps it will stop this one and allow this. So what are the strengths of the shared data pattern? All right. The first is that system components can manipulate data accessed by other components. So what this means is we're not just locking a certain, data to a certain component. Every system component might be able to access that data. Okay. The production of data is completely decoupled from their consumptions. Sorry, this means like a producer is decoupled from their consumer. There's no direct connection between the producer and consumer, so it is actually modifiable. The code itself and the application is modifiable. Right? Uh, Another one of the strengths is that it is very useful for when different data items are present with many accessors. So if there are several different accessors, okay, they can always use multiple data items since the shared data allows them to. There will be no need for redundant data. So if we can share a certain data source or data storage between several different components, you don't need to copy or create the same repository for each of those components separately, since they can all share from one. It is also easy to implement one-to-many data exchanges. So if a certain accessor wants to change a lot of data, it is very, very simple. However, shared data pattern is not without its weaknesses. It is quite complex to implement because you need to do synchronization. As I mentioned earlier, synchronization, you need to, for example, if we are talking about concurrency in most programming languages, you need to implement an intrinsic lock on each of the methods or the accessors so that they do not modify more than only one method so only one accessor at a time can modify a certain piece of data. If you can do it with two, it will relate to undesirable consequences. Next, shared data store might crash entire program if it fails. Okay, what this means is that since everything is in the shared data, it can lead to having a single point of failure. So what if if the data was separated to each application, say one piece of data for some reason crashes or for some reason is inaccessible, you still have all the other components can still function because they have their own data repositories. However, if we share data between all repositories, if the data is corrupted, every single component will not be able to function since it has lost all of its data. So this is one of the problems here, a single point of failure. Okay. Another thing, the data producer and consumer might be tightly coupled, so it makes it a bit difficult to modify it. Okay. More weaknesses. Okay, and overhead is introduced in all data exchanges because the data must be copied into and out of the data pool. Okay, let's assume that the data pool is actually the data repository or the data base. So since all the data needs to be copied into and out, obviously we'll have a performance overhead. So this will affect performance in a way that, say, if you don't necessarily in other architectures or patterns you might not need to do that. So it will be performance affecting and it's quite draining. That is one of the weaknesses of a shared pattern. So for my first example, I will put up Google Drive. Some background on Google Drive. It was launched in April 2012, not that long ago. Okay, it is the file storage and synchronization service launched by obviously Google. Okay, it allows us to store files in the cloud. Although it only launched a few years back, it's got more than 250 million users now. So it has been doing very well. Okay, so why do we consider Google Drive to be a shared data architecture? Okay, because it enables us to share a single data source to multiple people, okay, multiple parties. For example, a lot of different friends of ours who we want to see a single document. Also, other than just being seen by different parties, they can be edited by multiple applications. Inside Google Docs itself, we have several different third-party apps. Okay, for example, like creating Word apps or inserting image or image editing. All of these can access a single data source thanks to the shared data architecture from Google Drive. My next example is called EduRoam. It's less known than Google Drive. What it is an international roaming service for users in research or higher education and further education institutions. It provides researchers, teachers, and students easy and secure network access when visiting a different university. It's provided by participating universities like the National Research and Education Networks and also the Trans-European Research and Education Networking Association, also known as TERINA. Okay, so what does EduRoam mean if you haven't got it yet? Basically, just imagine now, okay, if we were to go to a different university, for example, on a study tour, or perhaps we've got there to access their data, okay, imagine now every time we go there, we need to get their own credentials and all. Okay, we need to get their university credentials, otherwise we will not be able to log in, we will not be able to use their internet. So what EduRoam does is, instead of having a separate credentials for each university, they have gathered up these participating and partnering universities. And if you are one of those participating universities, you just need one username and password to access shared data across all of these universities. So if you go over to another university, you can still use the university in your credentials that you use in your original university. So this can function the entire world over. It's very extremely useful to a lot of students and lecturers and researchers who travel overseas quite often. So finally, my verdict. Alright, I believe that shared data is really, really good. Okay, because it allows us to be borderless in terms of computers. I refer back to the EduRoam example. How useful would that be now that since we don't need to go to another university and go through all the bureaucracy of like trying to obtain another username and password. It's very simple. We can just use the one we already have, and we can do this all over the world. Um, then as for a benefit of Google Drive, obviously a lot of people can access and work on the same thing. We can share it with our co-workers or people who we're doing our research projects or assignment with. Other than Google Drive, GitHub is also very popular for this, especially when you're developers who are working on the same piece of code. However, it is actually very complex to implement a shared data pattern due to the synchronization issues that will arise from the concurrency due to having multiple parties accessing the same thing. So, in terms of coding it, there could be a lot of problems and unforeseen circumstances. Perhaps you think it might actually work, but if it doesn't, okay, then you might end up losing a lot of data. Okay. It's also a little bit troubling in the sense that it has a single point of failure. So can you really rely and put all your trust into it, knowing that if just that data center is corrupted, all of your data is gone. So, and it's very hard to convince people you're trying to sell the product to as well. So that is one of the troubles with it. Eventually, I think that it is very useful. So, but if you want to implement it, we need to do a lot of work, and you need to be very careful of security. And that concludes my presentation. I'd like to thank all my references and thank you for watching.